Okay, so next slide here shows that there are two ways to handle checked exceptions. We already talked about this. Throw the exception to the calling method or catch the exception and handle it. But there's also a situation where you can rethrow an exception out of your handler, right? So for instance, let me demonstrate a rethrow situation. So I might try something like this. Try this computation here and then catch the problem. For example, catch arithmetic exception. Okay, so I can continue on with my experimentation with these exception handlers, and I could say that here I can add another print statement and say that compute result, right? I could just print this on my screen. Compute result, compute result method caught a problem, right? So there's a problem with some computation. That's fine. Okay, so let's try running this, and actually I should probably compile it first, right? So if I go and clean and build this, oh, there's a missing return statement. Okay, sure thing. So here it basically says if you have those two alternatives, then you can just say return, I need to return something, so I'll just return -1. How about that? Okay, so let's try building this. So this finished building it, and so I'm expecting that this method here, compute result, will no longer have a way of throwing arithmetic range error, which is my custom exception class, right, object, because it basically says catch, and it does even some reporting, and it returns -1 because that's what the implementation currently does, right? So although it says method throws this arithmetic range error, it does not really throw it, right? So if we run it, we get the behavior which is kind of expected. We get this message that compute result method caught a problem, and that is quite expected because we purposely, always, throw new exception, and so it just happens. However, here's an option. Instead of returning, right, which looks silly, right? It basically says here, what it means to return -1. It's basically pretending that things went normal because the error has already been handled. Maybe that's not a good option. So perhaps what we can do is that we can say throw. Throw, just like this. Throw exception which already exists. And this demonstrates the technique to rethrow an exception. Okay? So you can, besides catching the exception, you can rethrow an exception again, right? So you could just go back to, go back to the catch handler, do some preliminary work with that error, and then just say throw and throw it again. And this, technically, you do not really create new object. You already caught an exception, and you just rethrow it by throwing it And if I run it this time, of course, the output is different. And of course, our finally block, runs, and we do display the the behavior which we programmed earlier in our main method right there, right? So we just say that if it's rethrown, we print the stack trace and so forth. Okay, now, so this is the technique that covers that rethrow exception situation. Now, we could rethrow an exception. A variety of this rethrow is that we could have constructed another type of exception, okay, just like this one, right? Another type of exception we could construct as new, right? I don't have a second custom exception class, so I'm just reusing the same one, and pass this get message, right? Again, pass this to the constructor, and so this way I can rethrow by generating brand new arithmetic range error and rethrow it. But this time, be careful with this technique, because if I run this, I no longer get information about the original exception, right? The only information that I get in my main method is that the compute result has failed, right? But we know, if we begin to examine this code more carefully, we'll realize that there was another exception which was thrown, and this was the result of this brand new exception being created. And so this type of technique can be kind of misleading, because you really have to have a good reason to do something like that. However, the original version of rethrow that I had, just like this, is quite reasonable and can be often found in the real code, right? So this is just a standard sort of like preview my error, do some work to do some extra steps here, and then just rethrow an exception and let the caller continue handling the error. So the good news about this is it's still your original object. It's not being reconstructed or altered in any way, so that when we get to run this, and in our main method we print the stack trace, we still get to the original method, the original method which created this exception in the first place, which was in this arithmetic Java, when there was an original throw new arithmetic exception statement generating brand new exception. So this is safe and quite usable. But I would try to stir away from techniques of regenerating a brand new exception object just because you can. I mean, that's why you need to choose your exceptions properly, so that they can be used successfully by multiple parts of your program, so that you can rely on the information stored in these objects. You can have exception objects that contain multiple data fields and store all kinds of application data, because it can really help to, you can even tell the user that your formula failed because you tried to use invalid parameters when you try to calculate your tax, or calculate your I don't know, like some linear algebra equation or something, and there could be some invalid things in there, and your exception could very successfully catch those parameters and tell the user, and eventually your program can tell the user that those are the parameters that caused this problem, which is very valuable information. Well, guess what? If you don't do that, your customers will be calling you with all kinds of questions, and you need to investigate it on your own. But you stay proactive and do more work to collect more data about problems which you handle on a regular kind of basis, then telling the user right up front what went wrong is obviously very valuable. And so once again, exceptions are the way to go with both system errors, runtime errors, and of course custom errors, application-specific errors, like the one that we're trying to demonstrate today with this arithmetic range error custom class. Okay, so we went over the rethrow, and so I can safely scratch off this rethrow exception topic, and so we talked about this part. So we still have some more talk about the multiple try and catch statements in your program. So this is the summary of the try and catch, and finally, of course, construct in the language. And so here's another example, this time using the file system, which of course we're going to be using in the future and discussing in detail. But here's an example of the read first line. Now notice that, so this apparently is a read first line from a file, and we provide a specific path to that file. Okay, so it shouldn't be difficult to follow at all, but notice that when we say string read line, this particular method, of course, could run into many problems with related to file input output, but at the same time, it doesn't say throws anything, which means that this method will handle all of the problems that it finds. All right, so let's just examine what's going on. In fact, we could just copy and paste this method into our code and see how it behaves and everything. Okay, just let's go here to our perhaps main method right there, right? So another method, just copy and paste all of this, right? So we copy and paste all of this. And obviously I'll go source format to make things simpler. Of course, random access file and file not found exceptions, all of these guys are to be found someplace in Java library. So I'm just going to use my typical shortcut just to say fix imports. And so the imports went on and found, and in Java IO we have file not found, and IO exception, and random access data. So let's now take it for our kind of review. So when we create a new random access file, we have to provide the path and the mode of access. In this case, this is a read-only input type of access to the file. So this comes back as a random access file named in, apparently for input. Then we say string line, read line. Okay, so read line. And then we return line because this method is returning a string back. So then this method is anticipating problems such as file not found. Of course, this path may be invalid, to a non-existing directory or file, and therefore it'll fail. Input-output exceptions would provide information about any type of situation under which other types of input-output errors have occurred. For instance, you could run out of disk space, or you can have not enough privileges to open that file, right? So the file does exist, but you don't have the right to open it, and you could get into other types of errors. And so this is why we use input-output exception as one of the types of exceptions we want to deal with. So we just report it as file not found, and also as input-output error has occurred. Now this particular try and catch statement also has the finally block, and it says here if we were able to actually generate an input, then under all circumstances, if this random access file input object is not null, then we need to close that file, and it's highly advisable to close your files whenever they need to be closed, because a non-closed file is another type of memory leak or resource leak on your system, so it's a good practice. And so even the close itself could generate exception in this situation. So notice that an attempt to close the file is also done under its own try and catch set of statements, which just catches the general exception, and it would still report to us that we were unable to close the file. So with this in mind, let's give this a try. Right? So there is now a method, which is a static method, that says read first line.